We extend our warmest welcome to all of you to the opening ceremony, Third International Conference on Science Development and Technology 2023. The Honorable Professor Dr. Hajah Nurhayati MAG, as Acting Rector of State Islamic University of North Sumatra. Oh ya. Jadi yang ini juga ya. Adukan aja berarti nanti langsung ini. Langsung opening speech. Berarti langsung ini lah ya. And the open ya. Air beriak tanda tak dalam, air diam tanda menghanyutkan. Izinkan saya mengucapkan salam untuk para hadirin sekalian. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah. Good morning, Excellencies, Honorable Speaker, distinguished guests, ladies and gentlemen. We extend our warmest welcome to all of you to the opening ceremony of Third International Conference on Science, Development and Technology 2023. The Honorable Professor Dr. Haja Nurhayati MAG, as Rector of State Islamic University of North Sumatra. The Honorable Dr. Julham SHI M.Hum, as Dean of the Faculty of Science and Technology. The Honorable Vice Deans, Coordinator, Subcoordinator, Chairman of the Committee, the keynote speaker, and also presenter and participant of Third ISOSTEC 2023. Firstly, let's pray and thanks unto our God, Allah Subhanahu wa Ta'ala, who has been giving us mercies and blessing so we can attend and gather in this event, namely Third International Conference on Science, Development and Technology 2023, which is held hybridly at the Swiss Berlin Hotel and Zoom meeting. Secondly, all prayer are present to our Prophet Muhammad Sallallahu Alaihi Wasallam, the greatest leader who has guided us from the darkness to the brightness. Ladies and gentlemen, the first agenda is the opening session by me, AMC. Let me introduce myself. My name is Rizky Amelia Nasution, lecturer of Biology Department. Now, we are going to the second agenda. Deliver our national anthem, Indonesia Raya, and March of State Islamic University of North Sumatra. Honorable, for all audience, stand up please.
Jamiatul Islamiyah Al-Hukumiyah Sumatrati Asyamariyah State Islamic University North Sumatra UIN Sumatera Utara Pusat pengembangan iptek dan seni berlandaskan Quran dan Sunnah Pancasila Undang-Undang Dasar menuju masyarakat sejahtera bersama UIN bangkitkan jiwa raga bersama harumkan Sumatera Utara bersama UIN jayakan Indonesia bersama bangun peradaban dunia Al-Jamiatul Islamiyah Al-Hukumiyah Sumatera di Asyamariyah State Islamic University of North Sumatra UIN Sumatera Utara Pusat pengembangan iptek dan seni berlandaskan Quran dan Sunnah Pancasila Undang-Undang Dasar 45 menuju masyarakat sejahtera bersama UIN bangkitkan jiwa raga bersama harumkan Sumatera Utara bersama UIN jayakan Indonesia bersama bangun peradaban dunia.
All audience, have a seat please. Thank you very much. Reciting the Holy Quran and pray by Indra, student of Management of Islamic Education Department. The time and place is yours.
Assalamualaikum warahmatullahi wabarakatuh. A'udzu billahi minasy syaithanir rajim. Bismillahirrahmanirrahim. وإذا قيل انشزوا فانشزوا ورفع الله فانشزوا ورفع الله الذين آمنوا منكم والذين أوتوا العلم درجات والله بما تعملون خبير صدق الله العظيم. السلام عليكم ورحمة الله وبركاته. أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. الحمد لله رب العالمين. الحمد لله على نعمة الإيمان. الحمد لله على نعمة الإسلام. الحمد لله على نعمة الهداية. الحمد لله. الحمد لله رب العالمين. والصلاة والسلام على أشرف الأنبياء والمرسلين وعلى آله وصحبه رسول الله أجمعين. اللهم اغفر لنا ذنوبنا ولوالدينا وارحمهما كما ربيانا صغارا، ولجميع المسلمين والمسلمات والمؤمنين والمؤمنات الأحياء منهم والأموات برحمتك يا رب العالمين. ربنا ظلمنا أنفسنا وإن لم تغفر لنا وترحمنا لنكونن من الخاسرين. ربنا تقبل منا دعاءنا إنك أنت السميع العليم. وتب علينا إنك أنت التواب الرحيم ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار وصلى الله على سيدنا محمد وعلى آله وصحبه وسلم سبحان ربك رب العزة عما يصفون وسلام على المرسلين والحمد لله رب العالمين تقبل الله منكم.
Opening speech by Chairman of the Committee, Mrs. Raisa Amanda Putri MCom. Time and place is yours.
Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillahirabbil alamin wassalatu wassalamu ala asrafil anbiya wal mursalin wa ala alihi wa sahbihi rasulillahi ajmain. Amma ba'du. The Honorable Professor Dr. Haji Nur Hayati MAG as Rector of State Islamic University of North Sumatra, the Honorable Dr. Julham SHI M.Hum as Dean of the Faculty of Science and Technology, the Honorable Vice Deans, Coordinator, Subcoordinator, the Committee, the keynote speakers, and also presenters and participants of 3rd ICOS Tech 2023. First and foremost, allow me to extend warm greeting and heartfelt gratitude to Allah Subhanahu wa Ta'ala for our presence here at this very special event, the 3rd International Conference on Science, Development, and Technology in 2023. This event holds a significant theme, Sustainable Technologies for a Greener Future, which is highly relevant in our efforts to create a greener and more sustainable future. Today we are blessed with the presence of the speaker from University Malaysia Perlis, Associate Professor Insinyur Dr. Muhammad Nazri bin Muhammad Warib, and from Universitas Padjadjaran Indonesia, Mr. Arjun Turni PhD, and at the Zoom meeting from Gokongwei College of Engineering, Philippines, Associate Professor Roy Francis Navea PhD, who have generously agreed to share their knowledge, insight, and experience in advancing sustainable technology. All of this would not be possible without the valuable participation of various universities in Indonesia. We hope that ICOSD Tech 2023 can be an ideal platform for us to collectively explore the potential and challenges of sustainable technology. We highly appreciate the hard work of all parties who have contributed to the preparation of this event. May this conference be an inspirational and informative forum for us. The theme of Sustainable Technologies for a Greener Future is not just a conference topic. It is a shared vision, challenge, and commitment to create a better world, one that is environmentally friendly and sustainable. Through this conference, we can share the best ideas, research, and solutions that will shape a brighter future for generations to come. To the participants, I extend a warm welcome and thank you for your presence here. May you all derive maximum benefit from this event and expand your professional network. Once again, I would like to express gratitude to all who have contributed to making ICOSD Tech 2023 a reality. I hope this conference will be a productive and inspiring platform for us. Thank you. Wabillahi taufik wal hidayah. Assalamualaikum warahmatullahi wabarakatuh.
Opening speech and open the ICOS Tech event by Dean of the Faculty of Science and Technology. Ladies and gentlemen, please welcome Dr. Julham SHI M.Hum.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah, alhamdulillahirabbil alamin. Wassalatu wassalamu ala asrafil anbiya'i wal mursalin wa ala alihi wa ashabihi ajmain. Let's thank to Allah who has given us mercy and blessing. So, salawat and salam to our Prophet Nabiuna Muhammad sallallahu alaihi wasallam, who has brought us from the darkness to the lightness. The Honorable Professor Dr. Muhammad Nazri bin Muhammad Warnib from University of Malaysia, Perlis. Welcome to Medan. The Honorable to Arjon Turnip PhD from University Pajajaran, Indonesia. And the Honorable to Prof. Roy Francis Napea PhD from Gokongwei College of Engineering, Philippines. And the Honorable to all committee, participants, presenters, and the speakers today. I want to express my appreciation to all of you for gathering here today at the third International Conference on Science, Development, and Technology. This conference is particularly special with the participation of the speakers from Malaysia, Philippines, and Indonesia. Our university is proud to be a part of this event and to welcome participants from universities across Indonesia. Sustainable technologies for a greener future is not just a topic, but a call to action. It highlights our collective responsibility to harness the power of science and technology to address environmental challenge and create a better world for future generation. I'm happy to see many participants in this conference. Let us use this opportunity to exchange ideas and collaboration. Together, we can contribute to a greener, sustainable future through our academic and innovation. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Thank you very much. Next agenda is photo session. Firstly, to all attendees who are present at Swiss Berlin Hotel, please come forward to carry out a photo session.
Oh iya.
Okay. Now, to all participants who attended the Zoom meeting, please turn on the camera and give your best smile. Signing of cooperation bet- between the State Islamic University of North Sumatra, the University of Malaysia Perlis, and University of Dharma Wangsa. We invite the representation to come forward. Well, ladies and gentlemen, we are going to the core agenda. That is presentation by keynote speaker. Without further ado, I would like to invite on the moderator, Mrs. Rina Widyasari MSE, Lecturer of Mathematics Department, and Mrs. Aninda Mulyani MSE, Lecturer of Information System Department. Then I leave the event to moderator.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. The Honorable dear Mr. Zulham, the Dean of Science and Technology Faculty, the Honorable our speakers, the Honorable our partner from Dharma Wangsa, and the committee and participants are all happy. Let us express our praise and gratitude to presence of Almighty God. Thanks to His grace and guidance, we can gather here today to hold a conference. I am Aninda as the moderator here, and my friend Rina Widyasari will be taking the minutes today. The series of our activities that we will carry out today are, first, its opening from us, and then the presentation of the subject, question and answer session, and closing. Well, since the opening sessions has been held, the next section is the presentation of the subject from our keynote speaker. I invite the presenters to explain the discussion participants, Mr. Arjon Turnip, PhD. But before we start the explanation, let my friend Rina Widya read the profile of him.
Well, ladies and gentlemen, let me introduce myself. I'm Rina Widyasari. I'm lecturer of Mathematics Department. First, I would like to read a brief curriculum vitae of our first speaker in Third International Conference on Science and Development Technology. Mr. Arjon Turnip received the Bachelor of Engineering and Master of Engineering degrees in Engineering Physics from the Institute of Technology Bandung, ITB, Indonesia in 1998 and 2003, respectively, and the PhD degree in Mechanical Engineering from Busan National University, Busan, Korea, under the World Class University program in 2012. He is currently working in the Department of Electrical Engineering, Universitas Padjadjaran, Indonesia, as a research and lecturer. His research area are integrated vehicle control, adaptive control, nonlinear system theory, estimation theory, signal processing, and brain engineering, such as brain-computer interface. Okay.
Thank you, Ms. Rina. And without long saying words, we invite our honorable speaker, Mr. Arjon Turnip. Good morning, Mr. Arjon Turnip. Place and time is yours.
Okay, thank you very much for the committee and also for the rector and the dean of faculty of Science and Technology of UIN North Sumatra for inviting us and give the chance for us to share the research result of our lab in Padjadjaran University with the big title of Artificial Intelligence on Health Technology with the study case of interactive autonomous medical robot. This research was funding by Research Collaboration Indonesia, which is collaborated with 4 institutions in Indonesia and one of the university from Vietnam. And then this is for the 3rd year. And then we are going to build the medical robot. So in the first one, as we know that in the research we need for the funding, and then it should be converting to the knowledge, and then in the future or after research, hopefully the knowledge can be shared to student and then can be converted again to the money. So this is the circle of the research. And then here I will present some of the research result, and also two of them already ready for marketing. Okay, so as we know, here we can see how fast the technology was changing from 2009 and 2019. It is have a big changing in the technology. For example, in 2009, the reporter still using the helicopter and the reporter, and 2019 it is changing and using only the drone. So everything have changing, and many things in our life also have changing, and then we can see that especially after COVID-19, the technology growing fast. One of them is nowadays the international conference held in the hybrid already. So we don't need to gathering together and then reducing the cost and so on. So nowadays we are focusing in the Industry 4.0. It means that it is highly contributed by the artificial intelligence and then Internet of Things, and we are now preparing for Industry 5.0. I mean, we are going for humanizing human with the technology like this, and then it is should be supported with the cognitive ability and soft skill and then technology. Especially for us, the academic should be ready how this technology has been changing, and then hopefully this research can support the development of the technology in the world. So in this presentation, I would like to present one of the example how the future our daily life, especially in the hospital, without the nurse. Okay, so now we are preparing the nurse in the robot, in the time of the robot. Okay, so yeah, as we see here, Industry 4.0, one single word that indicated the Industry 4.0, it is related to the all the algorithm building by Python. So this is one things that we are as a university. There is no curriculum about the Python, but the technology should be built by the Python. So how our student can be bring to that condition, and it is one of the challenging for us academician. And then the Industry 4.0 mean related to big data, Internet of Things, robotic, infrastructure of the and also interoperability. So it is already highly affected in all of the most of the agriculture, for example, automotive control system, digital control, computer information technology, education, and so on. It's been, if I get it from the World Economic Forum, in 2025, mostly all of this area will be supported highly with this kind of technology. For example, 3D and 4D printing, 4D printing, artificial intelligence, augmented and virtual reality, big data analytics, biotechnology, and cloud computing. So yeah, it is, most of these are embedded in our research today. So the background we have in the hospital, it is the infectious disease, economic improvement. It is to reduce of personal service equipment, and also in the automation era, mostly people want to be served. There is no want to be a server. So in terms of that, for example, in Singapore, for cleaning service, nobody want to be worker as a cleaning service. Therefore, the robot should be changed this kind of facility. So we are as a technological developer, we should be ready for this kind of thing. So this is the example. In the hospital, we are preparing the robot that this kind of thing can be solved. So the goal is we are develop this kind of robot that for it could be simply changing the part of the nurse in the hospital. So our purpose lab about the artificial intelligence, I show you briefly about the application of the brain for technology for the equipment. Here we build the wheelchair based on the brain-computer interface. Yeah, this is the scheme. This wheelchair has been awarded by our minister in 2015 and has been showing in all of the Indonesian television. If you can get it in the YouTube as well. And also we developed the technology based on artificial intelligence to detect emotion. It means in the case of the patient in the coma condition. Also, we apply the artificial intelligence for detecting the quality, the sleeping quality after consuming of the pala. This is the local planting in Indonesia. So we also have detect the effect of the one food called soybean to the brain activity. It is collaborated with PT Amerta Indah Otsuka, which is produced the Pocari Sweet. Yeah, we have made it, and this is the experiment. We get this paper has been published in the Open Agriculture Journal. And also we also conducted the brain-computer interface in order to select the leader candidate of the army. We did it in Bandung. So it is to reduce such kind of sambo like that. So it is to get to choose the good leader. So it is also can be effective for to choosing the rector, president, or university, or North Sumatra governor like that, and so on. So yeah, this is the experiment. So mentally we can select it is high impulsively or not like that from the brain, because using the conventional one, normally people already recognize and then they know what they need. So it is not reflected himself anymore. So this is the experiment. We also have make the brain-computer interface for impulsivity tests. We also from lie detection and also brain application for narcotic detection. And then in the last 3 months, we also have conducted the experiment in one of the prison in North Sumatra, in Binjai, for detecting the narcotic using brain-computer interface. Collaborated with Universitas Prima Indonesia. Okay, so this is we make it collaborated with Rumah Sakit Hasan Sadikin Bandung. Yeah, we can make the brain 3D or 2-dimension brain mapping. Also, we can make the mathematic modeling of our brain by having the information of the frontal and then occipital and other part of the brain. We can make the mathematical connection in this way. So we develop the mathematical like this. And then we can make simulation. So in order to, yeah, we also currently also we are collaborated with Akademi Penerbangan Indonesia, which is the pilot candidate. We detect the fear of the pilot candidate by brain like this. So it is maybe just a little bit when they flight, and then we record the brain directly, and then we try to detect what is the changing in the brain when the flight were getting take off and landing and such kind of doing maneuver like that. So okay, so it is also another. And we also have developed the portable smart cardiac halter. It is will be applied for the puskesmas, we call the health center. Yeah, so therefore our people or the community or society in the remote can do heart detection. And this is collaborated with PT Medista Indonesia, and this is the scheme. And then currently, this technology has been mass produced by PT Mers Medic partners, and then it is collaborated with Pajajaran University. So this is the scheme of our smart halter. And then this is the experiment. We built it in the website. The data are based on the cloud. And currently also this equipment, we put it in the emergency room of Royal Prima Hospital. So every patient, and then we get the data directly from our university, collaborated. Yeah, this is the website. So we also have developed the technology of detecting the movement of the baby in the mommy wombs. Yeah, so said it is to detect it is the healthy of the baby moms. Okay, this paper already published in the Artificial Intelligence Journal, and also we have built also smart renewable smart grid system. Therefore, we can monitor how the solar panel harvesting, and also it is a suspension system collaborated with President University. We get it the funding from BIMA by this year, and then we built for semi-active suspension to improve the comfortability and then safety of the car. Okay, so it is for using, and also we built the smart farming as well. Yeah, we collaborated. We get it from, and then also developing the drone, and yeah, here the main subject of this today's topic, it is development of the medical robot based on artificial intelligence for isolated patient. Okay, so this is the scheme, and this is the robot. This robot can communicate it with the human, the people pass by, and then also we can ask them to deliver food and medicine to different rooms simultaneously without sequentially, and also can do obstacle avoidance, can also many things also. I will show you briefly. Firstly, the robot will equip with the two-dimension lidar, and then it is mapping the room. Therefore, they will recognize all the condition of the hospital. So, this is the two-dimension mapping lidar in 3 building different. So, therefore, they can recognize all of them. And then we have tried to obstacle avoidance. Also, this is the simulation result. Yeah, this is also for delivering the food to different room simultaneously. So we can go first room and then secondly and the third and then come back to the nurse station like that. So it is, and then also this robot also equipped with 3D obstacle detection. I mean, when the robot can face the table or downstairs, so the robot will not fall like that. So this is the algorithm, we use it for the algorithm, okay? So it is also have for testing of vibration, because the sensor are sensitive with the vibration, with the mirror in the hospital, also the distance to the wall, and also in the turning area. So we also evaluated them all. So yeah, most of them should be covering with many algorithm, and then also using inertial measurement unit in order to detect the inclination of the floor. Yeah, all of them are based on artificial intelligence. And one of thing is here, yeah, since the robot cannot limit it with the movement in the hand, so in order to measure the blood pressure, the robot cannot put the conventional technology to measure the blood pressure. So we developed one of the technology, yeah, like this. This is one example. These things already can measure the blood pressure. So nowadays we only need using pincher to measure the blood pressure. Yeah, this is the result. The algorithm using NFIS, using CNN, we also try, and then also using another technology. So this is an example. So this subject simultaneously you measure in the hand. Yeah, this is the medical part instrument, and then one small things like this. This wireless connected to the yeah, like this, yeah, connected with the laptop. This wireless, And then we can see that it is highly close, 127, and then this is 128. So the accurate is quite good, yeah, okay? So this is one example, I bring it here. So this is also the robot equipped with the website. It can monitor anywhere and everywhere connected. This is related to the information system part of this faculty. So this is all, and then this also can communicate it like this. I don't know if the voice is clearly to the audience. So yeah, the human can do communication. For example, asking for where is who is the doctor working today, and then where is the pharmacy, where is the toilet, and so on like that. So the robot have been teaches about the area of the hospital, such that if one of the visitor asking for the robot, they can communicate it, helping like that. So this robot also has the ability to recognize, how can I say, for example here, if I measure the blood pressure, in case of the patient cannot read or cannot, the robot will say in English about the value of the blood pressure. So I mean the robot will converting the text to the voice like that. Yeah, I don't know, the voice is working or not, yeah. So this is, so every time the robot get the value from the sensor, it is converted with the voice, so such that the patient or the visitor can understand. So this is one algorithm that can be used for the face detection, for masking the mask detection, and this is the result. This also has been published in the journal. And also using the 3D reader, it is also to detect the downstairs and such kind of table, under table, such that the robot will not hit the table like that. So this is the simulation result. You can get it here. And then this is, we did it in our lab, and for obstacle avoidance and as well. Yeah. So as a conclusion, our smart medical robot for the isolated patient using based on artificial intelligence and Internet of Things has been built it and tested, and it is equipped with the tracking, localization, patient face detection, malware detection, obstacle detection. So in the form of the stair and the table, poles, and then also speed bumps. Biosignal measurement in the form of a heart rate, body temperature, and blood pressure. So several supporting technology also equipped with this robot with the voice the voice conversion, and so UV disinfection, and it is also has been tested with the accuracy of above the 95%. So in Indonesian research level, we assume that this is already TKT minimum of 7, and then we have made the draft of the patent in the 3 years research about age, and then we have submitted 10 journal, some of them already published, and then also some proceeding. So I think this is all of our research, and especially in the medical robot. And then at the end, I just want to say a little bit, no matter how difficult our situation, we must keep in fruitful like this. Even the papaya still, but they still produce in a good way. So thank you very much inviting us for sharing.
Thank you very much for Mr. Arjon Tunip, PhD. Give a big applause to Mr. Arjon Tunip, PhD. What a great presentation about medical robot technology that can use in brain-computer interface, EEG, and etc.
Well, before starting the question and answer session, I will read the several roles that we must pay attention to. Some of these roles are: first, the opportunity to carry out question and answer activities will be provided twice, with the number of questions of each occasion being 3 questions. 2, we will limit the question and answer session to around 5 minutes. And then, while the question and answer session is taking place, it's hoped to the discussion participants will always be orderly and calm. Okay, please, if there is a participant want to ask question, pleasant time is yours. Is there any question? Just raise your hand, please. It's not only for the online participant, but the offline participants here can also be asking question to Mr. Arjan. To Mr. Arjan, please. While waiting for the question, I want to talk about something to Mr. Arjan. Frankly speaking, I am feeling jealous, sir. Why only Royal Prim Hospital? Can it be held in our integrity lab? The result of your research can also be made into our integrity lab, laboratorium terpadu UINSU, Pak.
Yeah. Actually, this technology prepared for applied in the hospital. However, it is only actually the idea come from the COVID-19 pandemic. At that moment, we face this kind of condition. So mostly academia thinking about how to do something about to avoid this kind of situation. So it is started of this making the the robot. However, if we can see now, it is very difficult now. For example, in building the house, it is difficult to find the man who can do repairing. Sorry. And also in cleaning also, the higher of our economy improve, the more difficult for us to find helper, for example. So, however, this kind of thing will be needed in our life. So, what is the problem? For example, in Singapore, it is very high cost if they should use the human for cleaning service. So therefore, they thinking of using the robot. So many things, for example, in Indonesia also, such kind of thing already started. And in Europe, the nurse is already difficult to find. As I know, like Netherlands, normally import the nurse from Indonesia. So before this kind of thing happen, we need to prepare. So if Universitas UIN need such kind of collaboration, I think we can share it. Yeah, we can make the similar thing as what they need, because as we know, this kind of technology, artificial intelligence, means we can transform everything for daily life. It is called artificial intelligence. Yeah. Thank you.
Thank you, sir. Yeah, we still wait a question from our online participants. Ladies and gentlemen here also can asking question. I highlight a sentence, sir. Humanizing humans with the technology. I think that's a very great statement, because we know that human and technology kayak mana ya? It's not always come together, but you make a statement humanizing humans with the technology. I think that's great. Can you explain that, sir?
I mentioned about it is for in the future, it is called fifth industrial revolution, by mean in order to be survive, the human, the not only should be able to do cognitive ability, by mean solve the complex problem. Otherwise, if it is only the commonly, a robot can do that. So yeah, because as we know, the industry will try to get the benefit by using the human ability. It is very cost, and also human also can do lie. Yeah, can do telling a lie, but robot can will not do that, and human will feel, for example, it is tired, but a robot will not. But so many benefit will be obtained by industry by using the robot. However, so how about the human being? In order to make it collaborated together, so the human, we are academic or lecturer should be able to teach our student, to prepare our student in the future, which is our students should be have the cognitive ability, by mean to solve the problem, the complex problem, which is the robot cannot do that, and also by having the soft skill, and also having the the ability should be updated, and also should be familiar with the technology, because the technology will be around us from now on. That's the meaning of the humanizing of the human with the technology.
Mr. I would like to ask one question, because I'm a mathematics lecturer. Before, have you collaborate with the mathematics people? Then, how your advice to collaborate about your smart technology and mathematics? Yes. This is one question from Miss Eti Jumiati. The question is, in this material there is a composite material made from nutmeg, which will be used in how to apply it and what are the benefits, sir?
Composite material made from nutmeg. It is, yeah, I think it is, yeah. It is for sleepy detection, maybe. I didn't get what is the nutmeg. I understand it. But the material, if it is for the material for the pala, it is pala? Yeah, pala composite. It is design of aromatic, for, it is believed can improve the sleeping quality. So at that moment, one company collaborated with the hotel like this. So they want to provide that aromatic in each hotel collaboration, but they need to prove from the scientific part. So they come to us, and then we measure. We have experiment before. Consuming that pala aromatic, and then we measure the brain signal, and then after we put them go to sleep, and then we measure their brain, and then we can differentiate. It means, yeah, we get the improvement. It is similar with the soybean food. It is they believe it is could improve the brain activity every time they eat it, and then it could increase the ability. But in visually we cannot recognize it. It should be measured from the brain, like that, because everything in our body should be correlated with the brain. Yeah.
Sir, I wonder how smell can be mathematicized. Yes, I mean, how smell can convert into mathematic model. Can you explain that, sir?
Yeah, I think everything in the world is a mathematic. For example, when you falling in love, we also can make the mathematic model with them. Yeah, because it can be repeated. It is scientific. So, yeah. For example, in this condition, we put that things in this room, and then we go to sleep, and then we measure the brain activity. Yeah, we can make the mathematics from that, right? When we get the signal, and then we processing, we get the amplitude, we get the brain wave, alpha, beta, and theta, like that, so on, and then we can make analytic for that, like this. Yeah, I think all of them are mathematics. Yeah.
So the brain activity that can we build the model.
Yeah, from the brain activity. So we give input, and then this is the system. We measure the output from the brain activity.
Yes.
What will be the difference? Without that material, we measure, and then with the material, we measure again.
okay.
We make a comparison.
Yes.
If the brain activity getting increased or something changing,
Yes.
we can interpret it with something, and then we get the result like that.
Okay. Thank you, sir.
Okay, is there any question from the offline participants? Please, Miss Mrs. Triase, place and time is yours.
Why are robotic and AI synonym with Python? Is it only Python that can accommodate AI? What about other programming language? Thank you.
Thank you, sir, for the explanation. Participants here, is there any question? Or in online? Belum ada. Okay, sir, about the Python, can we can conclude that Python will take the main role of data, but in anyway, in our department, information system of WINSU has already used Python for subject data science as a choice subject on advanced semester.
Yeah, that's good. I mean, in
And
Pajajaran, not yet.
No, not yet.
We're still using the commonly.
Okay.
Yeah,
And the lecturer is Mrs. Triasa.
yeah, good. Yeah, you're lucky.
Yes.
Yeah.
And Alhamdulillah, our alumni can use the data science knowledge after they work
Yeah.
in out of campus.
That's it.
I think there are no questions anymore. Ya kan? So we can close the first session with Mr. Arjun Turnip. We can conclude that cognitive skill and technology must be updated to welcome the 5.0 the society society era. One more question, sir. How you can describe the amazing of society 5.0?
Of course, everything we choose will have two opposite sides, good things and bad things, right? So, in the good things, for example, nowadays we can communicate it easily using WhatsApp application, but a bad thing is something wrong also will be distributed fast, very fast. It is the weakness. So, the industry 5.0 also will also do the same thing. In case of the university are not ready with the coming of the 5.0 industry, then we will our university will produce how can I say unemployed people. Otherwise, ready.
Thank you, sir, for the great explanation. These are the concluding points that we agreed on earlier. I hope all discussion participants can understand them. That's our discussion today with Mr. Arjun Turnip as the first presenter regarding sustainable technologies for a greener future. Hopefully, it will increase our insight and knowledge and also can become a scientific reference for all of us. The next agenda is the delivery certificate to Mr. Arjun Turnip. Please, Mr. You can. Please give applause to Mr. Arjan Turnip. And the next agenda, we will continue with the second keynote speakers, Mr. Muhammad Nazri bin Muhammad Warib. Please welcome here, sir. Present time is yours. But before Mr. Muhammad Nazri start his explanation, we would like to read the profiles of him by Mr. Rina Widya.
Ladies and gentlemen, our second keynote speaker is Associate Professor Dr. Muhammad Nazri bin Muhammad Warib. He received PhD degree in Electronic and Electrical Engineering, Optical Networks in 2013 in University of Strathclyde, Glasgow, Scotland, United Kingdom. And in 2007, he received Master of Engineering in Electrical, Electronics and Telecommunication, Data Communication Networking from University Technology Malaysia. In 1996, he received Bachelor of Engineering in honors in Electronic and Electrical Engineering, in Networking and Telecommunication in University of Portsmouth, England, United Kingdom. And then in 1994, he received Diploma in Electrical Engineering from University Technology Malaysia. Currently, he is head of Network and System Integration, Center of Excellence for Advanced Computing, University Malaysia Perlis. His research interest, embedded system design, energy efficient, software defined network SDN, network on chips, optical networks, wireless sensor networks, VANET, and rehabilitation engineering. Okay, well.
Thank you, Ms. Rina. And then the next session, let us listening to the explanation of the presentation of Mr. Muhammad Nazri bin Muhammad Warib. Please, sir, the place and time is yours.
Thank you, Mrs. Chairman. Okay. Initially my presentation, we talk about energy efficient of network on chip for next generation network. However, before I proceed with the my research collaboration, I will introduce my research center. Okay, if you look here, actually I come from a Center of Excellence for Advanced Computing from UC Malaysia Perlis. Here is the location. We are located in Perlis, the northern part of Malaysia, and we are border with Thailand. Okay, next. Okay. Here is the facility. Mainly, our research is simulation based. Okay, but we still have a prototype, but we located in different laboratory. Okay, next. Okay, if you look here, here is the part of our team, research team, and if you look here, our mainly our research is on computational intelligence and data analytics, software engineering, human-computer interaction, high-performance computing, cybersecurity and networking, and image and signal processing. But my area is under networking and IC design. Yeah. Okay, next. Okay, here is our collaboration so far, local and international university, and also we have collaborate with industries such as Intel and Aruba. Okay, next. Okay, here as I mentioned, Okay, we have actually three area: intelligent computing, networking system and integration, and high performance security. Okay, next. Next. Okay, here is our currently our grant. I'm sorry because in ringgit currency, so it's total about 1.1 million. I think around 1 million rupiah. I cannot remember. Okay, 1.1 million ringgit. Okay, approximately 235,000 USD. Okay, so we have international and also local grants. Okay, next. Okay, here is our graduates from COE of advanced computing. Mostly our graduates from international, from Middle East and Indonesian, Brunei, and so on. Okay. Okay, next. Okay, here is the webinar and workshop activities that has been done by our COE. Okay, next. Okay, and okay, here also another MOU from other university and also from organization like cyber security organization. Okay, next. Okay, next. Here is the postgraduate workshop. First, as we want how to write a grant, how to write a PhD proposal, and so on. Okay, next. Okay. Okay, now we going to our research, main research. Okay, before I proceed with the more detail about my research, actually, my research focus on IC design. However, prior to that, I will explain about what is the next generation. I mean, we are collaborating with Telekom Malaysia. Okay, there are mainly their problem statement is high energy and power consumption produced by telecommunication operators. So before that, the IC design actually we focusing on the telecommunication equipment. Okay, so if you look here, the energy saving is a critical issue in telecom operator because it will involve capex and also budgeting for telecommunication company. Okay, if you look from 2010 until 2030, the needs for electricity is increasing. Thus, this involve a lot of money. And at the other side, this is the data rate or throughput for telecommunication. Okay, from 1 megabyte to 1 picobit per second, the energy saving, the energy consumption use is increasing. Okay, next. Next. Okay, here is the overview of the next generation network. In this case, fiber home. Okay, fiber home. If you look here, sorry, I explain. Sorry, because I not use laptop, so I need to stand up here. Okay, if you look here, this is we call it as a core network. Okay, this is the main telecommunication operation here. And this one, if you look, we have enterprise. Enterprise mean like industrial, financial institution. They are using this kind of network. Okay. And this one, fiber to the home, is our residential. Okay, residential network that we use, like our data here. And this one is all networks. Okay, legacy network. Okay, and this one actually is a legacy network, but mainly for enterprise. Okay, this is the equipment that been used for each of the location here. So if you look here, the core switches in this side is mostly is a huge equipment that produce more power. Okay, so there is many way to reduce the power. Okay, not necessarily from IC design. We can reduce in terms of use of the traffic grooming, traffic loading, and also equipment like electronic processing. Okay, electronic processing, optical to electrical converter. This all of energy that we can reduce, but not so much like inside the IC design. Because for example, I give you example like our desktop, right? PC desktop. The most energy dissipating is from CPU. That's why we have fan, right? We have fan to make it cooling. So same as telecommunication equipment, the most the major power consumption is from IC. So okay, next. Okay, so core router, core networks basically is located at the main city. Maybe in Indonesia perspective, like Jakarta, Medan, Palembang, main city. Like this case, because we are collaborating with Telekom Malaysia, so the main location is at the main cities in Malaysia. So basically, this topology is mesh topology. Okay, so that's zero, what we call like zero defect. We cannot accept a failure in our networks. That's why we call core network. Okay, next. Okay, this is the main equipment inside the inside the core network. For example, this is WDM. Okay, WDM is a wavelength division multiplexer. Of course, they are using light parts, light, as their means of communication, but still they have IC and board, okay, electronic board inside here. And this one is optical cross connect. Okay, currently most of these equipment are together. They are in one box. And if you look for the current and future, the box is become smaller, not like this big. Okay, this one maybe 2-3 years ago. Okay, but really it's become smaller. Okay, next. Okay, here is another the biggest equipment inside the exchangers. Okay, we call it core router. This is very huge until this side, and this one the most electronic processing happen in this equipment. So the purpose of this research is inside the board. Okay, we call it as network on chip. Okay, next. Okay, this one is metro network. Metro network mainly focus on the industrial area, like factories, and also education institution like universities, okay, and financial institution. So for the metro network, they are divided many topology, either partial mesh, ring, or optical WDM. Okay, next. Okay, inside that metro networks, normally the equipment is little bit small, okay, but still they have significant power consumption happen here. So this is another equipment inside the metro network. Okay, next. Okay, this router as usual. Okay, next. Okay, access network, or sometimes we call FTTH, or fiber to the home, or sometimes we call passive optical network. Okay, so if you look here, mainly access network is to residential and to end user. Okay, for core and metro, mostly in telecommunication side. For example, here we have two type of access network. One direct to enterprise, one is to residential. Okay, and residential we have two type. One is landed home, and one is rise home, rise building, like apartment. Enterprise maybe like hotel, maybe like factory that have rice building. Okay, next. Okay, in telecommunication side, normally we are connected with the equipment like this. Okay, even though you look like it's a passive, like cable, actually they are contribute power to each of these equipment. Okay, so our research focusing on core, but for the FTTH network, we do it for future, because the main power, 80% of the power contribution is at the core network. Okay, next. Okay, this is the setup for the telecommunication, like our internet at home. This is the design. I think in Indonesia perspective, quite similar like this. Okay, next. Okay, same thing. Okay, next. This one, if the main contribution on the FTTH, I mean in terms of power dissipating, is at the this one. Okay, because in this area they have amplifier that produce little bit power consumption. But remember, residential area is, even though the power contribution is not much, but residential area normally is they have large of population. Okay, next. Okay, so okay, next. Okay, if you look here, our main research not focus on this side. Okay, focus on the telecommunication side at the ground floor. Normally like hotel, right? We have we call MDF, main distribution frame, whereas our telecom equipment installed there. So this one. Okay, next. Okay, this is common. Everybody know that most outside there, we look like lot of wire. But this one is not electrical. This one is optical. So the main things, this one also contribute power, but not much. Okay, next. Okay, next. Okay, here is how the installation done by telecom side lah. Okay, next. Okay, next. Okay, this one is normally inside at the ground floor that I told you, but actually at the other side they have equipment. Okay. Okay, next. Okay, this is how networking at telecom site they are installed. Actually, they have two type. One at the overhead. Overhead is at our, like this one, cable, pole cable, and another one is underground. Okay, in Malaysia context, normally we doing at the underground, but here I think mostly is using overhead in Malaysia. Okay, next. Okay, so after that installation, actually this is how it look like in equipment room. Okay, next. Okay, next. Okay, this is fiber optic that you know, multi-mode, single mode, right? So this one is actually passive, what we call passive equipment. Okay, but they are not produce any power. But however, this box actually we design it for energy saving, for optical. Okay. Okay, next. Okay, this is another contribution that you know, wireless LAN. But you know that wireless LAN also contribute little bit power. But if the access point involve a lot of what we call more than 100 or 200, it also contribute power consumption. But in small scale is not significant. Okay. Okay, next. Right, another way how to reduce power consumption in core network, we call controller, namely software defined network, SDN. This is most popular now, SDN. But SDN in this context, we install in core network. Okay, so what happened, instead of this legacy equipment. Okay, legacy equipment mean the existing equipment using their own CPU. We convert all the signaling and electronic part at controller part, so that we reduce in term of power loading at the equipment. Okay, so we focusing SDN lah. Okay, next. Okay, SDN mainly the function is to control, to manage data, what we call data plane and control plane. Okay, that means signaling and also connectivity controlled by SDN. And SDN, in easy word, we call controller. Mainly the architecture divide to two. One we call it centralized. Normally this one is for metro network, and another one we call distributed control architecture, which is this one is focusing on core network. Okay, and this one is part of the way how to reduce power inside the core network. Okay, next. Okay, this one for metro network, very simple connectivity. So the data plane is this side, which is connectivity, and control plane, one of the signaling, we do some technique and algorithm to control in terms of light parts movement, and what we call another one is the active and passive equipment. So we control at the data in SDN. Okay, next. Okay, this one is focus. This controller, we call it multi-controller, normally located at core network. Okay, this one same concept at single, but this one we have additional function we call primary and secondary. So primary and secondary, they have depending how we want to set up our power consumption. Either we want primary active, secondary passive, that means standby, or we can do both active. But in this case, if you want to do both active, we reduce in terms of traffic loading. Okay, so this, they have two setup of power consumption. Okay, next. Okay, now we're focusing on chip, network chip. Just now I just explained about the next generation, how we focus the problem statement. Here is the how the chip has been designed to reduce. In this case, industrial and academia community apply NOC, same concept like networking. That means inside the IC we have router, switches, and we have resources like this one. So what is the problem inside the chip? Number one is number of core in terms of high energy, area of overhead, and increase the latency. This is the objective inside the IC. Okay. Okay. Next. Okay. So what is the objective to design the NOC? Number one, we want to use clustering power saving technique. This we design inside the IC. Secondly, we want to make less wire and a less number of hop, so that we can reduce in terms of energy inside the IC. In this case, we use segmentation connectivity technique. And number three is we call hibernation mode mechanism, which is we partition the node inside the IC design. Okay, next. Is it understand? Okay. Okay. The main contributor here is number one, like I said, because we want to make power efficiency inside the network chip. Okay. The contributor here is to clustering, to partition, and to segmentation. Okay. Next. Okay, next. Okay, the evolution of network on chip actually is starting from 1985. Okay, but in that time, the most industry using this is IBM. Okay, that time the design inside the IC is using custom. Okay, and then towards the 1990, okay, Sony, Toshiba, IBM, they produce shared bus connectivity inside the IC. So this one improve in terms of performance, but they don't care about energy. Okay, just performance. Same thing goes to 1995. They are improved in terms hierarchical bus. Towards 2000 millennium, they're using bus metric. 2005 point to point. Okay, they are using point to point connectivity. And starting 2010, then the industry thinking about energy saving. In that case, the generation is different. We call it network on chip. This is what I want to talk about. Okay, network on chip, totally, the objective, we want to maintain the performance, okay, but we reduce in terms of power, then we can reduce in terms of our capex. Okay, next. Okay, the architecture for NOC, same like network generation, next generation network, which is we have routers, switches, resources like your RAM, your memory, and so on. Okay, and then this apply to either in network interface, either interlink or into the router and switches. But remember, this one is not the equipment. Okay, this one inside the IC. But the naming is similar. Similar like the name of equipment. Okay. Okay, next. Okay, this is the parameter that used to measure and to design the NOC. But in this case, we focus on topology, static, hybrid, dynamic, and we focus on network flow control. Okay, we cannot do everything, but we focus on this kind of techniques. Okay, next. Okay, inside the NOC, they also have topologies. Okay, mainly topology is torus, mesh, and ring. The rest is they have a research doing that, but we're not focusing on 3-spin, bus, star, and BFT because this is very simple connectivity. But for torus and mesh is for large IC design. Okay, next. Okay, this is performance metric that we use. Okay, mainly this performance metric. Okay, focusing on distance. That means distance inside the IC, area of IC, network throughput, power consumption, and power latency product or PLP. So this is the formulation for NOC. Okay, next. Okay, what is the technique? Okay, because we have router and switches. Okay, for the router side, we use topology based on either sleep mode technique, hop count technique, reduce router count, wiring inside the IC, and also hybrid topology. That means torus, mesh, or ring. Okay. Okay, next. Okay, this is the comparison from previous research. Mainly same, we focus on area, power, latency, throughput, response time. Okay, next. Okay, next. Okay, for this technique that we apply in NOC, okay, actually we have 3 techniques. We call clustering, segmentation, connectivity, and partition. Okay, and this power technique, they have mechanisms. Okay, for the clustering, we use sleep mode. Sleep mode is normal. That means we make it deep sleep. Okay, deep sleep for the equipment. But however, for clustering, can only suitable for line, ring, and cluster. Okay, for segmentation connectivity techniques for power saving, we using mechanism. We call it as standby mode or standby mode link. That means inside the IC we can do standby, and the link itself we can make it standby. But this one we focusing on 3 segments. That's mean for tuning stable power. And number 3 we call partition power saving technique. Use hibernation mode. That means we hibernate, look like deep sleep. Okay, and this one only suitable for mesh, torus, ring, and partition. Okay, all these technique we apply at core network and metro network. Okay, next. Alright, this is the comparison, clustering, segment, and partition. Okay, for the clustering, we can apply all topologies. Okay, but for the last one, partition only happen in mesh, torus, and ring topologies. Okay, next. Okay, this is the state diagram. Okay, how operation of energy saving happen. Okay, either busy state, that's mean 1, link state 0, because we are digital, right? 1, 0. So this one is the state. So either 1, 0, and the operation is like this. And this one is the this kind of like 1, 0 technique. Okay, digital, we have ideal is 0, busy is 1. Okay, okay, next. And this algorithm that we implement, mainly, like I said, we apply in torus, a ring, and mesh. Okay. Okay, next. Okay, this experiment, I mean in simulation part, actually we test for two type of nodes. One is 6 node for small connectivity, and for large connectivity we use 64 nodes. Nodes mean in your IC design we have 16 nodes, and another one in our design we have 64 nodes. So in 60 node, we test for mesh, torus, and ring. This how it. This is how the topology look like. Okay. Okay. Next. So the result for this test, actually we use a simulation that we customize ourselves. Actually, we do it ourselves. Okay. So if you look here. The important thing is the performance analysis, which is we want to see area, power, latency. That means latency is delay, okay, and power latency product. So how much the delay happen versus to number of node, packet injection rate, and buffer size, and also number of virtual channel. Number of virtual channel is the link. Okay. Okay. Next. Okay. Like I said, power saving we use 3. Okay, clustering, segmentation, connectivity, and partition. And next, and mechanism is sleep mode, standby mode, hibernation mode. So in this one, we apply to our simulation. Okay, so next. Okay, so what happened? I make it simple for this presentation. I focus on 64 nodes for large network. Okay, what happened? If we using clustered segmentation topology in mesh. What happened? Our finding is around up to 78% can be reduced inside the IC. Whereas for the partition topology, significant power saving, which is around 90%. Okay, so both is okay, no problem, but it depends on the topology that we use. Okay, next. Okay, this one when we apply at torus, okay. If torus, we find out the power consumption not much significant. The reduce is around 68%. If you look here, so compared to mesh just now, torus just now. Okay, next. Okay, this one is a ring. Okay, if we apply this technique to the ring. Around 40% to 50% can be reduced. Okay, so for the large network, it recommended using torus topology compared to ring or mesh. Okay, next. Okay, this is the comparison. If you look here, 16 nodes and 64 nodes. Okay, this is the data that we gather from the simulation. Okay, next. Okay, so what is our finding? For 6 node, using clustering, we found out that lower power consumption due to simplicity design. Okay. However, for partition ring, we find out we can reduce in terms of latency. That means the delay is less. Okay. For 64 node, for large network, okay, segmentation connectivity ring. We find that we can get the lowest power consumption, but for lowest latency, we apply clustering torus. Okay, next. In conclusion, okay, the design of clustering and segmentation connectivity techniques reduce the total power consumption in mesh, torus, and ring up to 71%. Okay, the design segmentation connectivity technique reducing the number of hop in clustering mesh by connecting each segment in 3 topology up to 40%. Okay, standby link in segmentation connectivity, we can save up to 1 until 74% power consumption. And by efficiently handling the connection of partition technique, achieve up to 4 to 59% power saving compared to traditional mesh and torus. And finally, an efficient management clustering segmentation, connectivity, and partition topologies by sleep mode, standby mode, and hibernation mode up to 98.83%. Okay, that's all. Thank you.
Okay, my thanks to the presenter for providing a clear explanation for us. And next we will continue the question and answer session. And before starting the question and answer session, I think I have given you the role, but I will repeat it. The roles are: the opportunity to carry out the question and answer activities will be provided twice, with the number of questions on each occasion being 3 questions. And we will limit the question and answer to around 5 minutes. And while the question and answer session is taking place, it's hoped to the discussion participants, it's offline and online, always be orderly and calm. Okay, is there any question in this room? I mean the offline participant? How about the online, Miss? It's not yet. Belum. Yes, while waiting for the question, I can conclude that this research is about power consumption. Our power saving. Yes, the power consumption is a focused thing for electronic company, and the technology to support it is very needed. Since the fast technology development, and we can take the conclusion that clustering, segmentation, and segmentation connectivity and partition technology is 3 ways to get the power saving. How about this participant in this room? Is there any question, ladies and gentlemen? Is there something you want to ask to our speaker?
Okay, I would like to ask to our keynote speaker, Mr. Muhammad Nazri. Oh ya, ada yang bertanya. Okay. From the Zoom, for the first, is for from the Kori Dwi Anggraini. What are the next technological development in telecommunication after fiber to the home and 5G? What are the next technological developments?
Okay, currently FTTH, fiber to the home, or mainly we call passive optical network. Okay, the main thing that future research is on the speed and energy. That means we increase in terms of data rate. Okay, currently in Malaysia context we offer 2 gigabit per second, but actually we can up to even 100 gigabit per second, but it's depend on WDM equipment in core network. Okay, so the future is two element. I mean data rate and also the energy consumption. So of course energy consumption we need to design IC. Okay, but the problem with the IC industry, we cannot make more smaller. The only thing now is nano. Okay, nano technology, and the only thing we can do, the size is fixed. We cannot make it small. So the only thing is technology, in terms of technique, how to play around inside the area. Okay, so that's the thing. So what happened in FTTH? The IC design, and also increase data rate and reduce power consumption.
Okay. For the next question, for me, your research is about power consumption and energy consumption. In mathematics, we have the graph theory. You know graph theory. This is collaborate with the network. Have you researched about the use the minimum fiber or cable with the power consumption? I mean that have you researched about we use the minimum fiber, yes, or cable in collaborate in power consumption or power energy, because in graph theory it is have a minimum spanning tree that have the collaborate with the minimum use the cable or the fiber. You can explain it, okay, sir?
Right.
Yeah.
Okay. You said spanning tree mean graph theory.
Yeah,
Graph theory, right?
in graph theory,
Okay.
that's minimum spanning tree or shortest path. Ya kan, because kan we can use the cable, ya kan. In mathematics, we want to optimize by using the minimum cable. Is there collaborate with the power consumption or energy consumption? Have you researched about it?
Yeah, we
Okay,
do, but mostly simulation. But I explain to you, okay?
Okay.
Okay, in network, we divided to two. One we call local area network, one is wide area network. Wide area network mean core network, okay? In spanning tree, only apply in local area network. That means internal, inside the building. But for the telecom, we not apply spanning tree, because spanning tree mean you have primary, you have secondary, one is down, can take over, right? Or both is active, but you can load balancing. Okay, all right. Okay, how to reduce number of connectivity? Okay, in theory we call we have if we can remember, we have 7 layer. Okay, OSI 7 layer. Okay, optical is layer 1. I mean physical layer. Okay, and IP router is network layer, layer 3. Okay, both are using routing, but in physical layer, optical, we call it RWA, routing wavelength assignment. That means how we route the light, how we route the light, and for the IP we do routing, IP routing. That means we route packet. Okay, same concept but different things. Okay, for this case is a physical layer, layer 1. How do we route light? Macam mana kita nak reflect? I mean, how do we route light? We should have mirror, right? Mirror. So reflecting. So the equipment, inside the equipment, they have a lot of mirror inside there. So they do routing. Okay. When we do routing, we can reduce in terms of connectivity. That means we optimize using any algorithm to optimize the way how to use fiber optic. Actually, in most of people don't understand. Actually, inside the core network, I mean, the big one core network, in one tiny fiber optic, we can carry up to currently up to 160 light in small one. Small one. That means there's a lot of light inside. 160 light. Logically, we reduce 160 right. So that's mean by using WDM, we reduce 160 we call light or sometimes we call channel. Actually, in that one run on logical, not physical. Physical is like fiber optic, right? So just imagine if one tiny one we can carry 160 light. How about 120 core? 20 core mean in fiber optic we have 120 times 160. That's we reduce a lot of connectivity, right? That's the way how to reduce connectivity. So.
The next question is from the participant on Zoom meeting. How to respond to the development of sustainable communication technology and its impact on children's education?
Ini berat ni soalan ni. Okay, actually communication, right, is connecting between one place to another place. Okay, that means from Malaysia to Indonesia. Actually, we can do online, alright. So this is how we communicate human. Okay, but in this case, I'm here lah. Okay, to explain. Okay, communication actually we helping humanizing in term of to make far away to make become near. That's the humanize. That's the answer. Sorry, just now you asking about energy. Well, let's say I read a journal. Sometimes they are not consistent with the words, power and energy. Okay, if you're talking about energy, you just focus on joules or in our electronics, we call energy per bit. So focus energy. Don't mix energy and power. Sometimes you say watt, sometimes in result you say you find in watt, but in conclusion you say energy. So make sure you understand the mathematical first. Okay, so not the different, this is a conversion. Correct? That's.
Okay, sir, I wonder, is what you as the researchers that did support to a greener future, to our greener future, sustainable technology of power consumption, support to a greener future?
Okay, of course, we always support the sustainable, greener, right? That's why my research is green, a green network we call, and energy consumption, right? So, okay, nowadays, if you look, most of the activists, they are saying about, blockchain, okay, blockchain, Bitcoin, okay, Bitcoin. Okay, they said Bitcoin produce a lot of energy, okay, a lot of not sustainable, okay, that means data center, okay, but actually, comparing with the financial institution bank, they actually use almost 70% of power consumption because they have a lot of data center compared to blockchain and everything, because blockchain is the future of technology. Okay, we cannot avoid because nowadays blockchain is easier to what we call to do a transaction, and also we can validate our information. For example, our certificate, right? Certificate. there has a lot of bogus certificate. Your degree, your bachelor, master, PhD, everybody can. Bogus mean tipu, right? It's not good, right? So with the blockchain, and blockchain is support of greener network. Sorry. So this kind of technology is sustainable. The researcher always think about the greener and always think about sustainable, and we can sustain this technology and grow. That's important of our research. Okay.
Okay, I think Mrs. Trias, you want to ask something, please.
Ini parah, Pak.
Yeah. 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 Thank you, Prof. Yeah, I think we have intersection of research. Okay, so you have about networking, and then in our case, actually, it is related to the artificial intelligence, but also need communication. And then one of them, as you mentioned in the beginning of your talk, that it is highly related with the image and data processing related to the connectivity. In our research, normally we face such kind of problem about the latency. So when we send the data, and then actually we need, for example, the big problem when we develop the drone, when the drone sending the data, actually we need to observe the information in real time, by with small latency. But somehow, as we know, in Indonesia, the connectivity networking still limited in some area. But maybe you have any suggestion, for example, of using networking, also of using protocol, also of maybe related also to the algorithm for the processing. As I mentioned before, we are using the Python algorithm application for developing all. So because we are not in the part of them, we are only use the available in the but don't have any ability to improve that kind of problem. So we are only try to select where is the good one. For example, when we have already detect the latency problem, but still we don't have any ability to improve them like that. So maybe in that cases, if you have any suggestion for us, it will be helpful for us in developing this kind of technology in this part related to the remote and communication like that. Thank you.
Thank you, Doctor. Okay, number one, I have no expertise in drone, but I try give suggestion.
Yeah, it is only example.
Example. Okay. Okay. Drone, when we involve drone, that means we involve on distance, right? Okay.
Also
moving, right? Geographical, right?
Yeah.
Geographical area. Okay. Okay. Number one is communication between drone and us.
Yes.
I mean the controller, right?
Yeah, yes.
Okay. There's involve what we call wireless communication, right? Okay. Wireless communication is depend on geographical. Either in this place environment. Okay. Is it ideal environment? Either means zero factors, or impossible for zero factor. Normally, at least if we have the environment like haze, altitude,
Yes.
altitude and so on. Okay, number one, how to reduce in terms of latency. Of course, the nearest is less latency lah.
Yes.
Okay, right?
Yes.
If the far is a lot of latency, right? So this involve frequency, right? Okay, and also power transmit. Power transmit, not power consumption, power transmit, right?
Yeah.
The far is less latency, more latency. Okay, but the only thing we can reduce here is the protocol. protocol used by to communicate.
Yeah.
Maybe I'm not sure. Maybe currently the protocol is big in terms of size. If we can segmentize, that means the protocol make it smaller. That means the faster they can send faster and receive faster. So there's another area that we can reduce in terms of protocol. Okay. Secondly, the power. If we produce more power transmit, faster, faster receive.
I see.
Okay, but the problem is battery.
Yeah. Yeah.
The battery problem, right?
Yeah, problem.
So for me, there's many factors we need to improve in terms of latency. Not only just protocol, not only of course geographic factors, environment factors is one of thing, right? But I think a lot of things. That's what I can say. Sorry if I cannot answer that.
Yeah, thank you very much. Okay, thank you.
Thank you, Mr. for the clear explanation. From the audience of this room, is there any question? Maybe Ms. Triasi want to ask something? Or Mr. Yusuf, you want to ask something to our keynote speaker? Because Mr. Yusuf is the major lecturer of networking in ilmu komputer. Because there are no questions anymore from the offline and online participants, so I think it's the time to make the conclusion of the presenter, the second presenter. That the developing technology that support by artificial intelligence needs more and more big data, and the equipment for big data must be supported with power saving. I think it's the interesting fact of first speaker and second speaker. Okay, Mr. Is our very we are very thanks. We say very thanks so much to your explanation. And the next agenda is the delivery of certificate to Mr. Muhammad Nazri. Place and time in yours in front of you, sir.
Belum buka dia. Ini belum. Mr. Roy Prancis Navea, can you hear my voice? Okay, ladies and gentlemen, we are going to the last keynote speaker. Is Roy Prancis Navea, PhD, from De La Salle University, Manila. Let me introduce Mr. Roy Prancis Navea, PhD. He receives his bachelor degree in electronics and communication engineering from the Mapua University Intramuros, Manila in 2003. A PhD degree in ECE from De La Salle University, Manila in 2012 and 2017. Currently, he is an associate professor in the Department of Electronics and Computer Engineering of the Gokongwei College of Engineering, De La Salle University, Manila, and served as the Assistant Dean for Research and External Affairs of the School of Innovation and Sustainability, De La Salle University, Laguna Campus. Now he handles a major ECE course in the undergraduate and graduate school and do research activities in the field of digital signal processing associated with acoustic, bioinformatics, and biomedical devices, electronic and communication network, power electronics, and Internet of Things that also include artificial and computational intelligence. Please welcome Roy Prancis Navea, PhD. Time is yours. Yes? Okay.
this man is selling. Now that you have learned that, every time you see something like this, then you will know that this is a soft-talking seller. Okay? So now you learn that. Okay? So that is how we learn. So we learn by familiarizing ourselves with the different things that we see, we hear through our senses. But one of the most important thing and very famous as of this day is what we call the artificial intelligence. So this is actually the intelligence of the machines. Okay? So these are human intelligence that we give to machines to capacitate them to learn, to identify, to characterize, to determine, and even to predict something that our capacity cannot do. Okay? So because they have long range and they are scalable up to a certain level, or as ideally infinite, so not just like humans. So these artificial intelligence are basically what we have right now. Especially, it became more famous with the advent of what we call the ChatGPT. And currently, if you are using your Facebook, so there are a lot of photo apps, okay, so that are available right now that can create images of yourself. So you just have to take a selfie of you, and then you can have a lot of different pictures that really looks good. Okay, so that's the power of artificial intelligence, not just in the field of entertainment, so in automation, in manufacturing, in education, in the banking system, in the economy, and even in the government. So there's a lot of application of artificial intelligence. If there are a lot of things to learn, okay, so AI can be there. So we define artificial intelligence as a simulation of human intelligence which combines computer science and a robust data sets. So these data sets serves as the learning information so that the machine that we are training to become more intelligent will become really more intelligent. And this will enable them to solve problems. Okay? So there are some limitations of humans that the machines can do. Okay? So for example, how do we edit photos? So if we are going to do it manually, so it would take time, it would take resources, and it would take more power. Since the conference is about sustainability and moving to a greener future, so with this solution, so it would take lesser time, lesser energy, and more efficient and more economical. Okay, so that's one aspect of being sustainable. But there's another aspect that is not that good. So they say that every time we use a certain device for computing, okay, so it causes or it requires a lot of water to counter the heat being generated by the servers that we are using in order to come up with a certain result. So what are the origins of AI? Okay, so basically, artificial intelligence came from a Turing test. Okay, so that was as early as 1940s and 1950s. So the term artificial intelligence was first used in 1956 by John McCarthy. And as it goes on, so we have a lot of developments going on related to artificial intelligence. We have the natural language processing software, so which was introduced in 1965 and currently being used to analyze Facebook chats, Facebook posts, or other social media posts to determine the level of stress, level of depression, and something like that. So in 1979, so we have the Neocognition Artificial Network. 1986 is the neural networks widely used with the black propagation algorithm. And we have the Deep Blue computer that defeats, the famous champion Kasparov in chess. Okay? So a machine beats a human, so when it comes to this game called chess. So in 2006, Amazon launches EC2 Cloud Computing Services, and Apple launches the iPhone mobile revolution, so in 2007. So in 2010, just a decade from now, before now, so we have here the development of Watson computer that defeats crucial Jeopardy champions. and the group of virtual assistants like Siri, Google, Cortana, and Alexa. So these are the different evolutions of artificial intelligence. Just like if you are going to just simply say, hey Google, so it will respond to you, oh, that's like that. So my phone responds to me when I say, hey Google, okay. And if you are going to say, hey Siri, so your iPhone will respond to you and ask what you need. Okay? So with that innovation, so there are a lot of platforms that were also developed, so including the deep learning frameworks, AlphaGo Kids, Champion, Layers Alike. So these are the different AIs that challenges human capacity in terms of sports. And also in 2019, so we saw FDA establish its foundation for a potential approach for pre-market review of AI. And in 2020, just this, few years ago, so we have the OpenAI's the GPT-3 that produces language just almost indistinguishable from humans. And there will be a lot of evolutions in the years to come, so related to this AI. And because of that, we have to be very resilient on how we are going to deal with these types of technologies. And in the future, some are actually afraid that these technologies would replace humans in different aspects of life. Let's say job security, so will it be replaced by machines? So will humans be conquered by machines in the future? So just like sci-fi movies that we are watching from the Hollywood. So these are the common science fiction and trend that in the future, what will it be? Will we going to be still humans, or are we going to become androids, something like that? Okay? But it's not that possible. So we have chips which are implanted in the human body, so that contains artificial intelligence. And it's not possible that in the future there will be a cybernetic organism that we will be encountering as time goes by. So there are different branches of AI. So I guess we're familiar with machine learning, so that contains predictive analytics and deep learning. So speech, so that's text to speech or speech to text. So for example, when I go to other countries like in Japan or let's say Korea, so they have a different characters. Okay? So if I go to Canada, so I use my Google Translate and take a picture. I will know what is its translation in English. So it's a good tool for travelers who are not familiar with the different characters around the world. So we have also image recognition and machine vision, so which are currently used in driverless cars, and these are used for authentication in our devices and different other security measures. We have the language processing, so that's used for classification, translation, and data extraction, and even integrated expert systems, planning and optimization of our schedules, of our plans, and even in the application of robotics. So there is a contrast between artificial intelligence and what we call the natural intelligence. In terms of AI, so in terms of speed, we can say that AI is very fast. Okay? A doctor can diagnose in 10 minutes, but an AI can do millions at the same time. Okay? So if they will be deployed in different areas and do the same diagnosis, an AI can do that 10 times as compared to a human doctor. But when it comes to the natural intelligence, it is more energy efficient because it will only use 25 watts for an AI for the natural intelligence, but for an AI, it would require 2 kilowatts to do this diagnosis. But we just have to strike the balance between efficiency and the energy consumption that it will provide. So AI can operate 24/7, while NI is universal. So humans learn 100 of different skills in a lifetime. But if you're going to teach a robot how to dance or how to do a certain task, so it would take some time. So AI is less biased, while natural intelligence is multitasking, And in terms of accuracy, AI has a better accuracy, higher accuracy as compared to NI, but NI has complex movements as compared to artificial intelligence. And since there are more people as compared to machines, so there's an abundant supply of natural intelligence, and we just need to provide proper education so that this intelligence can be used for good rather than for the bad. So these are the pros and cons of artificial intelligence. So for the pros, the advantages, so we have, it reduces human error. It allows for quicker decision making because it just click in the button, so it will give you results. It reduces risk, automates repetition, and assists with digital tasks. So if the task can be done by a human, so it can be done by a machine. So if there's a risky task that a human will do, so we can use a robot with AI so that instead of, for example, if let's say a high risk task, so instead of using a life, so it's better to use a machine, okay, so than to use a life. Okay? So recognizes patterns, identifies human workflow improvements, and expert in working with large data sets. That if you are going to ask a human to do that, so that will be very hard for the person. Okay? And for AI, it does not or never works out easily, but of course, in the long term, so it has to be updated. So the cons of AI are the following. So it requires higher overflow costs. So initially, so when we established this one, so it would cost us a lot. And it may cause job loss. So there are parts or certain aspects that AI can do, so it may introduce some job losses. But it also lacks the ability to be creative because it has to be programmed, unless there are some ways, or it is self-contained, or it can become more creative, like the photo apps that we are having right now. It's more creative than before. Okay? It also has emotional range. It lacks emotional range, so because machines don't have feelings or emotions. But there are some technologies that we are developing, especially humanoid robots, so that we can develop some sense of emotion or feelings. And for AIs, it has the inability to integrate ethical and moral principles unless it is grounded or hardwired in the system, and it increases the likelihood of human laziness. So maybe for those who are here in the academy, you can observe some of the students are becoming more lazy or less patient, so they want more results and faster because AIs and the different devices that we are using produces much faster, and they are used in handling those types of systems. So my area is in the healthcare, so because I am working with an institute, so we call it the Institute of Biomedical Engineering and Health Technologies. So I am into the biosignal processing and the development of some AIs when we develop different devices related to healthcare. So artificial intelligence in healthcare so brings a lot of advantages. And in relation to the theme that we have, sustainable and greener future, so AI in healthcare optimizes healthcare services through high-efficient systems that we can see in different medical institutions. Some are low cost, low waste, and low carbon footprint. By reducing materials, hardware utility, through scalable and adaptive software intelligence. We can also see wearables and reducing the size and the materials needed in the manufacture of healthcare devices. So promotes development or greener usage of materials and the introduction of wearables and other mobile health devices that will serve the health requirements of the community. In terms of energy, it can possibly reduce energy consumption by using low power devices, especially the wearables. And if the services can be done mobile or remotely, so mobility advantages due to remote operations lessens the need to travel, and it can improve or lessen our carbon footprint. So what is AI in the healthcare industry? So in terms of the usage of AI in the in healthcare. So we see an increase in the market potentials of AI and AI-driven devices in healthcare, so which is anticipated to reach about 19.25 billion by 2026. So up from 0.95 billion in 2017. So there are a lot of opportunities right now, especially in the healthcare industry, when we implement AI and those devices that could possibly be used to become more efficient and effective in terms of solving healthcare problems, so which are utilized by our healthcare professionals. So how is AI used in healthcare? So there are a lot of different areas where AI is used. So AI can be used in health monitoring and wearables, as I mentioned. So we have personalized healthcare plans. In cancer research, AI is also used. Dosage error reduction, medical diagnosis, drug development, rare disease diagnosis of patients, virtual nursing assistance, even fraud detection, AI can be used. In cybersecurity, so it just needs to be used in the good side or in the white side of cybersecurity instead of the black side of the cybersecurity. Because there's what we call a white hacker and a black hacker. So we can also use AI in gene editing and also in artificial intelligence robot-assisted surgery. So similar to one of our projects we have here in the university. So one of the benefits of artificial intelligence in healthcare are the following. So we can use AI for early diagnosis. Okay? So because AI is data-driven, so it decides based on the information through a database. So data about patients is being analyzed with AI-driven tools to determine their health issues in the past and in the present. And it can also predict on what could possibly the diseases or any other health problems that the person can encounter. So AI can also be used to reduce costs and increase speed in terms of diagnosis. So healthcare processes are faster and cost of a fraction of what they once were because of artificial intelligence algorithms. So there are sensors that are being used, okay, to determine our responses to different stimuli. So by sensing different biomarkers that could possibly indicate disease. And these AI can also identify these markers and can possibly provide some indications and help our practitioners to diagnose a certain person. Okay? And with that, this could possibly minimize the amount of manual work that must be done to define these biomarkers. So maybe you are familiar with these themes if you are watching Star Wars and other different sci-fi movies. So AI can be an efficient and unique surgical assistant service. So there are more hospitals in the first and second world countries that uses robotic surgery. And with that, we could possibly see an improvement in terms of healing. So those who are gone through surgical robotics are found to heal faster as compared to the normal or the manual surgery. Okay, so we can carry out complex operations more efficiently and with fewer side effects, blood loss and pain problems, and recovery after surgery is quicker and easier. Okay? But there is a disclaimer here that because it depends upon the case of the surgery. But for general surgery, so it is found that robotic surgery is quicker and easier. So AI can also enhance human abilities and improve mental health. Okay? So this is one of our research also. And robots are also helping medical staff and patients through exoskeleton. Okay, so to improve movement, and in the same way, so there are smart prostheses powered by AI, so featured by sensors that offer more rapid response than traditional prostheses. So currently, we are developing technologies related to immersive technologies like VR or the virtual reality, and those augmented reality that is related to healthcare and that target specifically Medalcom. So currently there are a lot of startups revolutionizing healthcare in this year, so in 2023. So let me go through them and share with you. So most probably, so you can work with these companies if you are working with different AIs related to healthcare. So let me start with RAD AI. So this is a power radiologist for the future. So RAD AI only saves radiologists more than an hour daily. Imagine that, more than an hour daily by automatically generating impressions from dictated files. So this is based in the US and it was founded by Dr. Chan and Gerson in 2018 with a funding of $32 million. So there's also what we call the BrainSight AI. So this is an MRI-based SaaS platform and able greater precision in neurological and psychiatric investigation. So this helps patients shorten the path to recovery and good health by leading from informed estimation of data-assured diagnosis and data-predicted prognosis. So this is based in India and founded in 2019, and most of the applications are used in MRI, SNMRI, and digital phenotypes. So the third one is the Camila. So this is found in the United States in 2018. So this is a medical technology software and services company that's developed for ultrasound. Okay? So imaging technology for the developing world, and they also developed what they call the e-scope device. So this is the first FDA and CE software-based ultra-portable ultrasound for point-of-care and specialized imaging. Another is the Octopus Health, which is founded in Israel in 2018. So this is a patient engagement platform for proactive population health, and this technology creates a healthcare personal assistant that supports millions of patients around the world, and it can reach a lot of people through its advanced machine learning algorithms. We also have the Biotech Medical. Okay, so Biotech Medical was founded in Kenya in 2018. So this is a data-driven procurement platform for hospitals. So if there is a need for supplies and data procurement in the hospital, so this Biotech Medical can be used as a platform. Another one is the Switch. Switch is founded also in Israel in 2013. So this is an artificial intelligence-based platform for large-scale prediction, prevention, and outcome improvement of chronic diseases like diabetes, hypertension, hyperlipidemia, and obesity. Okay, so they believe that every individual should live a healthier life, so because we have the right to live a healthy life. And currently, there's no scalable and cost-effective solution to this ultimately diabetes. So you can search for Switch as one of a good platform when it comes to this one. So we also have the Celery Health, which is found in the US. So this is a software platform that screens and assesses patients' everyday experience using patient-reported outcome tools from the NIH PROMIS system. So they do daily monitoring of everyday experiences and even the activities of the person, so that it can possibly predict or determine several possible problems and anticipated attack or some triggers in the body. We also have the RevKit. RevKit is founded in the United States in 2017. So this is a software that helps healthcare providers simplify the post-payment medical audit process. So not just in the specific healthcare, but also in the processes of healthcare. So like in the other one that I mentioned, that's in the procurement side of healthcare, but this one is on the post-payment medical audit process. We also have the Droxy. Droxy is an AI tool, so this is found in Israel. So it reduces the amount of time spent on non-patient facing tasks and improve the quality of care by creating patient-specific storytelling. Okay? So Droxy identifies and visualizes most relevant medical factors for each task, so physicians can quickly cross them off their list. So because if there are some things that are not needed, so this software can cross them out and medical practitioner can go directly to what is more important. We also have the Arden Ahead. So this is a charitable project, more than 30 active volunteers from around the world. So it uses crowdsourcing, and they work with thousands of people to die preventable deaths every year by developing an oxygen concentrator that is more affordable, consumes less power, and produces oxygen reliably for years. So this is found in USA and in New Zealand. So we also have the Dumor Diagnostics. Okay? Dumor Diagnostics is on a mission to transform cancer diagnostics with artificial intelligence to improve patient care and make drug development more effective. So if there are some people who are suffering or early stages of cancer, so this software can possibly help in determining what is the possible stage and what could be the drug that could be more effective in treating that particular cancer. We also have the Dr. Tag X. This is found in Zimbabwe in 2016. So it uses deep learning algorithm, which is built on a computer-aided diagnostic system to help doctors diagnose medical images more accurately. So this system can help doctors in terms of analyzing X-rays and other visual, biological, or bioinformatic information. So we have the SHIELD. So SHIELD uses the power of AI to eradicate and stop virus transmissions of all types, so which is found in the USA in 2020. So maybe this was triggered by a pandemic, so because there's a lot of virus transmission during that time. And this would be a good solution in stopping other viruses from spreading. We also have the Realize. So this is found in USA in 2015. So this uses machine learning to transform care from reactive to proactive so that more people can live healthier lives. Another is found in the United Kingdom in 2018. So this is the PEP Health. PEP Health is an automatically defines and gathers millions of publicly available feedback items from various online platforms, so including social media, and it helps in setting policy for opportunity to listen to their patients, learn from what they say, and measure their experience. So this is more of a qualitative platform wherein they can possibly hear the sentiments of the patients related to their health. We also have the Blue Care from the United Arab Emirates in 2019. So this is a full-service digital therapeutic diabetes clinic, so which is available in UAE, and it uses AI to do the different applications related to bariatric management, cardiology, and also diabetic food, clinic, and thyroid. We also have the Parahealth, so which is found in USA in 2017. This is a healthcare company that provides asset-light services like home care, telehealth, remote monitoring, and other technologies. The Enhero Health, found in USA in 2017, so has deployed a total population health management solutions that includes provider, patient, and payer-focused solutions. So they provide support systems and payers with unparalleled expertise and knowledge achieved through data analytics and improve outcomes of patient experience at a lower cost of care. The 3PM was found in the USA in 2018, and this is a multidisciplinary team that provides analytics, consulting, training, and modeling services, for example, for medical hospitals and for those healthcare providers that uses or that looks for advanced systems in healthcare. In 2012, so Ignis Health was found in the USA that helps manage telehealth, so telehealth services, so in line with hospitals and other healthcare systems. So this was very useful, especially when we are dealing with patients in a very remote area, and this would help them to reach medical services even when they are far. The Anchor Health was found in USA in 2017. This is a consulting and analytics company, so that specializes in the practice management and physician alignment. And the Kiva Health, so also in USA, This is a digital platform that uses AI for providing respiratory, remote care monitoring, and it creates personalized care experiences for respiratory disease patients. The WISE Care or the WISE Healthcare System was founded in 2017 by Sajid Ahmed in the United States. So this virtual medical assistant facilities provides accurate and convenient medical consultation and diagnosis services. And lastly, the Big Bio. So this is found in South Korea by Suwoki in 2015. So this is an AI-based cancer pathology image analysis solution, so which is available with or without HDX viewers, so which was mentioned in the previous slides. So these are the different startups in the healthcare industry related to AI that are producing a lot of applications, innovations, and revolutions, innovating our healthcare, especially for government. In our country, here in the Philippines, so through the efforts of the Institute of Biomedical Engineering and Health Technologies, so we have government-funded projects through the Department of Science and Technology, Philippine Council for Health Research and Development. So through the Neurotech, or this is actually the Neuro Robotics Technology Program, I lead this program, and under this program, so we have 3 research projects. So that is, they are the CELIA project, the IBALIN project, and the SIGLA project. The CELIA project, so the names of the projects are basically taken from Filipino words. For example, CELIA, it means chair, CELIA, right? So because it basically works with an integrated EEG integrated wheelchair. IBALIN means to return, okay, or to restore. So in the IBALIN project, so we want people who have suffered from stroke to restore their normal function after having a stroke. So IBALIN means to return or to restore. While SIGLA project, SIGLA means the excitement of the person, excitement. So this is an AI-based technology that we are developing targeted for people who are suffering from depression, because we want people who are suffering from depression to regain their happiness and their excitement in life. So that is the concept of SIGLA. There are other projects that are under the Institute of Biomedical Engineering and Health Technologies here in the Philippines, so which is implemented by the De La Salle University. So all in all, we have accumulated a funding project of 350 billion in our local currency, and that is equivalent to 6.2 billion US dollars for all of the projects that we have in the institute. So currently, we are working with the Neuro Robotics Technology Program. So this is a locally inter- and transdisciplinary program that integrates the fields of neuroscience, robotics, and artificial intelligence. We also work with medical people, like people in the field of technology, because aside from the machines, the technology that we are developing, we have to target the people who will be using these technologies. So it's not enough for engineers to design, to model, and to create prototypes. So there have to be people who will be using these devices in the bedside, in the hospital, in the clinic, in the houses. Just to introduce our project, so the CELIA project is an EEG integrated wheelchair power unit for patients with physical disabilities. So by definition, this is a brain-controlled wheelchair for people with disabilities. So its main objective is to provide the means for people with disabilities to improve their mobility using the mind power over a motorized chair. So for the IBALIN project, it is defined as a cognitive and motor function rehabilitation using neurofeedback training system for stroke patients. And this project aims to provide solutions designed for stroke patients so that we can restore their original function. So this is a VR-based technology. so that translates the normal or the traditional way of therapy into something that is digital and objective in nature. The third project is the SIGLA project. So this is entitled the Depression, Recognition, and Analysis from EEG. So towards virtual reality-based therapy programs. So the SIGLA project is a neurofeedback therapy solution designed for people diagnosed with depression. And this came from the concept of, in Filipino, that's ibalik ang sigla. So it means to restore the happiness, the enjoyment in life. So which is something desired for people with depression. So what are the challenges that we are currently facing in doing research? And of course, so this will not stop with research. So we want these devices to be available in the market. So there is a concept of commercialization so that our knowledge and intelligence through these systems can be used by the community. So currently, so there are challenges in terms of funding because in some of the researches, so initially there has to be a funding source, okay? So it has to be funded by an institution or supported by the government. So perhaps in your country, so there are also, your government is also providing funding opportunities for your research projects, but eventually the project should not end as a prototype. It has to be commercialized and be brought to the market to be used by the people. And as we go through that particular process, funding is a very important factor. So since we are developing technology in healthcare, so data privacy and security is an important matter. So we have to develop systems that are very robust and secure so that we can protect the information, especially the health information of our respondents, of our clients. There are different ethical standards in different countries, but there are gold standards that all countries follow. So aside from developing the devices, it has to go through ethical approval so that it can be made available to the public with its security features as well as its safety, which is also, it has to go with and comply with the regulations and governance of the country where that device is being developed. So there are also dilemmas when we talk about AI, robots, and other technological development that it would possibly dampen the use of or the services of humans. So that's why there are still some people who are afraid of AI and machines in healthcare. There is also a lack of transparency when it comes to AI because of what we call the systems. It has a black box, something that we can really figure out what's inside. And there are some mechanisms in the AI that could possibly lack transparency and understanding. In terms of intellectual capacity, so we have to capacitate our people in the use of modern equipment. And also, this will start, of course, with our students who are developing these technologies, as well as the people who will be working with us in terms of developing these technologies. So this is a challenge, especially for hiring people who are not aware of these technologies, so they have to be capacitated. And we have to identify the landscape of the market because we could be developing devices and advanced technologies that are not really needed by the people, by the market. So we have to identify or understand what is needed by the people, so before we develop things. That's why even in the stage of proposal or project proposal development, so we talk with different stakeholders and those who will be working with us in the field of, let's say, medicine, psychology, or even in general healthcare. So that we know that there are those people who will be benefiting from these technologies. In the future, so these are the things that we can possibly see in the future related to AI, machine learning, related to healthcare. So AI is already transforming patient care, clinician practice, and pharmaceutical operations, and we are only at the beginning of the journey. Artificial intelligence will be used in healthcare for various tasks, including answering the phone, reviewing medical records, analyzing population health, designing therapeutic drugs, devices, services, reading radiology images, diagnosing situations, and even conversing with them. According to the World Economic Forum, AI will access multiple sources of data to reveal patterns in diseases, and aid treatment medical systems will be able to predict patients' risk of certain diseases and suggest preventive measures, and these advances will lead to shorter waiting times for patients and improved efficiency in hospitals and other healthcare institutions. Thus, with AI, health systems can provide truly proactive, predictive healthcare. As a closing remark about my talk, so this is taken from a movie. So this is Terminator Salvation. So the character there is Marcus Wright. So he said that what is it that makes us human? It's not something you can program. You can put it into a chip. It's the strength of the human heart, the difference between us and machines. Given that we have this technological advancement, robotics, artificial intelligence, let us not forget that we are still humans. And we have to treat everyone fair, with humility, with respect, even we have advanced technologies. So with that, thank you very much, and I hope you learn from this talk. So there are some questions, so please feel free to ask, and I can be reached for possible collaborations through this email, rodat@lsu.edu.ph. Thank you very much.
Okay, a very big thanks to our presenter, Mr. Mario Frian. And the next agenda is we have a session of answering questions. And for the first time, I am going to see the questions from the online participants. I want to give the chance to the participants in this room. Ladies and gentlemen, is there any question for Mr. Navea? Miss Ulfa? Miss Rizky? You have any question? Maybe? Or Mr. Arjun?
Feel free to ask questions. I'll be happy to answer your questions or queries.
Mr. Roy, can you hear Mr. Arjun's voice?
Yeah. Can you hear me, please?
Yes, I can hear you.
Yeah, okay. Thank you very much. Yeah, I think you give us a lot of information about the application of the artificial intelligence, especially in the healthcare system. Yeah, actually, I also applied the artificial intelligence and Internet of Things, also focusing in the healthcare technology. However, maybe could you give us your advice about your experience of using such of algorithm, for example, when you should use the machine learning, and when should to use the deep learning, for example, in the healthcare, especially when the system connected with the remote, like that. Thank you.
Okay, so thank you very much for that question. So I appreciate your research works also related to AI and IoT. But of course, when it comes to the application, so we use different algorithms depending on the application in healthcare that we are using. So about your question, so in the usage of algorithm, well, it depends. So first, it depends upon the application that you are working with and on the data set that we are also using. So if we are working with a lot of data sets, so better that we could possibly
use deep learning algorithms. So because if we are going to use the, let's say, the normal, let's say, neural network systems and something like that with a large scale or large number of information, so this would require a lot of computing power, and this would also require a lot of resources from our system. So if there are some applications that does not require much computing, okay, so it does not require a lot of information, then we can use minimal AI or those that simply uses prediction models. So like those from, of course, let's say in other software that we could possibly use. So if you are working with images and different high, let's say high capacity data, so it's better to use high-end machine learning algorithms, and together with that learning algorithm, it has to go with your hardware, because the hardware requirements for high computing, there should be a match between them. So it's hard to perform high capacity AI in a lower scale hardware because it will take you a lot of time or even days for your system to learn. And in addition, it's highly recommended, but of course you have to consider data security, to consult or to use cloud services that will possibly do the computation in the cloud instead of using it locally. So there are a lot of systems right now, especially mobile and remote, that uses the cloud services, and the results will just be brought down to the, let's say, for the wearable device for the analysis and the results.
Thank you. One more, please. Nowadays the big data, everything related to the big data, and then the data already based the cloud technology. So, yeah, especially about the healthcare information. What do you think about the security of having the healthcare information in the cloud? Because actually, for example, in my cases, I'm the engineering part related to the control and artificial intelligence, but not in the cloud system or security system. For example, when I develop the technology, and then someone or the audience asking, how do you make sure if when the data in the cloud and it for wrong using of the somebody like that? In your opinion, how do you believe of using the cloud technology?
Yeah. So when it comes to the cloud
technology or the cloud services, so of course it concerns data security, data
privacy, and the one that is being feared when it comes to this one is the data breach. Okay? So currently in our institutions, we usually have a network, let's say network administrator that handles our information, for example in the hospital, everything like that. So with the local services that we have, so for example, so you simply hire, let's say, a faculty or even a person who is good with, of course, data security and management. But, there's a lot of people who are trying to access different systems, especially the government or even the private sector. And it is highly recommended to use outsourced experts when it comes to data services and security. But of course, when it comes to outsourced services, so you have to determine you have to identify their reputation in terms of handling security and services, and also their reputation in handling data information. So because in our experience here in our country, in the Philippines, so I'm not sure if you have heard in the news, so there are some government agencies here in our country which are being hacked. So some of the agencies experiences data breach. So maybe because their infrastructure, their personnel when it comes to this one is not that good, or maybe not advancing their knowledge about data security. So as compared, let's say, with the black hackers, okay, so who are continuously identifying, learning what are the new technologies, the encrypting and the decrypting technologies for data security. So there should be a continuous learning and updating of what's the current trends when it comes to data security, and it would be costly if you are going to work with it, but the benefit of that is you will have better, and let's say the peace of mind that your data are secure. So because if you are just going to have someone from, let's say, from the university, so for example, your faculty is teaching data security to students, how would you know that in the future the student will hack the system of your university, something like that, right? But of course, if there are third party protectors of your system, so you can rely on them, and in terms of security and in the risk management, so it will be based on that third party, let's say, institution, instead of handling it yourself. Okay? So you transfer the risk of data breach to them, so not to your institution. But you just have to work on the resources required for that. Because in our assessment, it's better to invest on data security than to pay those people who will be breaching your system. Like a ransom, you know that ransomware. So it's better to invest in security more than paying these people who are hacking.
Okay, thank you for Mr. Arjo. Mr. Navea, this is a question for the Zoom meeting. How does gen editing using AI work?
Again, how
does gen editing using AI work?
Gen
Editing using AI work.
Oh, genes.
Yeah,
Editing. So you mean the genetic composition of the person?
Yeah.
Okay,
Yes,
okay,
yes.
gotcha. Yeah, okay. So actually, genetic editing has to do with different components of the gene. Okay? So it has different chemicals in it, different proteins, and these have different characteristics. Okay? So their characteristics are being quantized, so which are fed in an AI system. So if there are some things that needed to be edited, so for example, this particular gene sequence has, let's say, it has an outlier, or it has a problem with this particular gene sequence. So that AI can determine that this gene has a certain problem. So it has detection features, it has classification features, and also it can possibly predict, or let's say, it can give us a recommendation on what could possibly be the best combination for this particular gene sequence. And that is where gene editing comes in. Okay? So because imagine that these genes are just time sequence data, and then this time sequence data could be analyzed, fed into an AI, and then it will possibly do detection, classification, and even recommendation. So that's basically how it works. So that's the basic
model, but there could be some advanced ways on doing that. So implementing advanced algorithms related to machine learning. So, am I able to answer that question?
Thank you, Mr. Roy, for your explanation. There are already 3 questions, and I think it's enough for this session. So, with the end of explanation of Mr. Roy, it means that our session for this conference is over, and we can continue to the conference session of the presenter privately. So once again, we say big thanks to your explanation, Mr. Roy. Have a more successful over in our future. Thank you.
Thank you very much.
Is the delivery certificate to Mr. Roy? Chairman? Ada. Your certificate will be shared into your account, Mr. Roy. Thank you.
Okay, thank you very much.
Thank you very much, Mr. Roy. Okay. Ladies and gentlemen, Mr. Roy Prajastapaya is the last keynote speaker. Please give applause to all keynote speaker and for you all. Thank you. I and my best friend, Mrs. Adinda Mulyani, would say thank you very much to Mr. Arjun, to Mr. Muhammad Nazri, and Mr. Roy Navea for that given us a lot of informations, a lot of knowledge about technology and its development in facing 4.0 industry to 5.0 industry. Okay, see you later on the next ICOS DT, and I will give to our Master of Ceremony. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Ini juga ya. Apa nih? Bajuannya ya?